What's up, YouTube? Welcome back to my channel, Techademic, where I just touch on all kinds of technology stuff, specifically at this point in time, programming, and more specifically in the NodeJS and React sphere of tech. So in today's video, I want to touch on and kind of expand on a previous video I did where I did a deploy of a Next.js on Google Cloud Run using GitHub Actions. And one of the questions that came out there was, how can we make the container a bit smaller? So I mentioned in the video that you could get it down to like 150 to 200 megabytes. And today I want to show you how the different base images compare and how you can get it to be smaller, and maybe the smallest you can get it for a Next.js type application. So I'm just going to switch over to Visual Studio here to show you what we'll be doing. So firstly, this video is based off an article that I found online written by snick.io. I'll provide a link to this repo at the end, and you can go click on there and read the article. It's very detailed and very nice. And then also this video builds on the previous video about deploying Next.js on Google Cloud Run using GitHub Actions. So what will we do? I'm just going to do multiple builds of exactly the same project, but using different base images. And then a little bit of a spoiler, towards the end, we'll try and get it as small as we possibly can using the Node Distroless images from Google. So let me just, I'm not going to, I made a previous iteration of this video that had some problems, for which this one is a replacement. And I built all of them like while recording the video, and it took a bit too much time. So what I'm going to do is just, I prepared everything and I'm going to show you the results. And then the last one is obviously what you're all here for, because that's the smallest one. I'll show you how I do that and how I run it. So let me just switch over to a little presentation. Essentially, you'll see at the top it says something like node default. That's the name of the branch in the repo if you want to go and grab this code. What we'll be building is a simple Next.js app, and then just measuring the size of the image that comes out. So the first one is just the normal official, how should I put it, the normal base image that your typical developer would use, especially during development time, not necessarily during production time. But it's got all the bells and whistles in there, and it is quite big, to be honest. So it's the normal Docker file that you're looking at here. It says from Node, and that is the current LTS version as of 25 November 2022. You switch over to a working directory, copy some files over, you run the npm clean install, you build the app, and then you just start it. And the result of that is an image that is roughly 1.2 gigs in size. Now, if space isn't a problem for you, there's nothing wrong with using this image. Most things will just work. There's nothing wrong with using it, apart from it's quite big. Next in line is the same variety of image, but it's the slim variety thereof. In other words, bulk has been trimmed out of it. The rest of it works exactly the same. It builds the project, and you end up with an image of roughly 490 megabytes. So, that's almost it's just over a third of the size of the previous one. So unless there's a very specific reason that you need to use the full image, this is the one that I would recommend in most cases you go for. It's built on Debian 11. It has some vulnerabilities, which the article I mentioned earlier on can tell you more about. But yeah, this is a good base image to work off. The next one is NodeBuster. So it's almost the same as the previous one that we looked at. Well, it's not make it two back of those. So the Node default one. It's almost the same. The difference being it is based on Debian 10. So Debian 10 is end of life, I think 2024, if I'm not mistaken, which means this is not a long-term solution for you. It will work perfectly fine. It will do what you need it to do, but it's not a long-term support version. and as such I don't recommend you use it. The steps are exactly the same, and the output is still 1.17 gigs, so you can see it's almost the same as the previous images that we looked at. Next one is called Node Bullseye. Again, this is an official image, same as Node Buster. And what you will quickly see when you run a build on this one is the size is pretty much the same as the first one that we did. And that's because it's just a different name for the same thing. It's the same build from Debian 11. It's got the same libraries. It's got the same everything. Node Bullseye is just the more correct, or the more code name way of saying the same thing. And then the same happens with Node Bullseye Slim. It's the same as the Node default one, the Slim one. If you build it, you get to roughly the same size as well. So yeah, Node Bullseye and just the normal base node will pretty much give you the same thing. That's what it boils down to. The next one is Node Bullseye LTS. More of the same, difference being this one will focus on LTS versions of Node only, whereas the normal Bullseye one or the Node one will give you the latest version of Node. So this one will give you the LTS version as it is at that date in time. And the size is still 490 megabytes. It is a slim version of the Node packages. Then, next in line, Node Alpine. So I discussed this one in the previous video. And essentially, Alpine will work fine in 90% of the cases. You will get a relatively small image. I'll show you the size just now. You'll get a relatively small image. Most of the, like the Next.js app that we're building at this point, it will work perfectly fine. But Node Alpine is not an officially supported image by the Node.js guys themselves. It's an unofficial build. It's based on Alpine Linux, which is extremely small, which is why the image sizes are so small. But the main difference between an Alpine variety image and a Debian one is that an Alpine Linux uses different C libraries. So if you interact a lot with the lower system libraries, especially C libraries, you might run into some problems. And also Node Alpine builds have been known to cause issues with yarn running in the background. So just be aware of it. It's perfectly fine in most cases, but if you start running into problems with Alpine builds, especially when you work with lower level system libraries in your Node code, and you use something like Node GIP and so on, you might run into problems. Right, so output 424. As you can see, that's the smallest one we've had up to now. And that's a decent decrease from the 1.2 base image, so definitely something to consider. And then, last but not least, is the Node Distroless images. So what are Distroless images? Distroless images are, first off, if you look at the bottom here, it says from GCR Distroless. So GCR.io stands for Google Container Registry, which means this Distroless image is provided by Google in this case. But it's got nothing in there apart from something that can run your built application. It doesn't have any package manager like apt or PIP for Python or things like that. There is really nothing in there apart from just a runtime where you can execute your application. What that means is you can't build your app in this Distroless environment, and you need to use what you call a multi-stage build. So stage one then means use whatever image you can. In my case, in this case, I just used Node 18 Bullseye Slim, and I give it a tag or a name. I call it build, and then you just do the same thing that we did in the previous builds, and you set up a working directory, you copy your code over to a specific directory, and you do an npm install, and then to get all your modules installed, and then you just build your package. And then you take whatever you've built there into the second stage of your multi-stage. In this case, then you use your Distroless image from Google, and then you copy the code from the build image in the user source app directory to the user source app directory in this build that you're doing, or this image that you're using here. Then you change your working directory to that, and then you can execute what you've built in step one of this multi-stage. So what does this result in size-wise? Let's see, 448 megabytes. And I can immediately see your reaction being, but you said this is going to be smaller. Well, theoretically it is, but the problem in size here is not the Distroless image, it's the size of the Node.js application and all the modules that are in there and things like that. So, before I show you the results of the final step, I want to show you how to do the final step, which is trimming it down even more. So, in the environment that you or in the code repository, you'll see all the ones that we just went through, and the last one there is called Node Distroless Smaller. So I'm going to check out that repository or that branch, and then there's two things that I want to show you. The first one we need to just check. I'm going to delete this Next.js folder because that's where the build files go. When you do npm run npm let me just close that, sorry. npm run build, it goes into the next folder. So I'm going to delete that folder and let us start from scratch. And then I just want to comment out something here in the, I mean, that is the crux of it, but I want to do it without it first. So we do npm run build, and now we build the Next.js project. And then in there, we can see all the Next.js files. So this is what goes into the image and what essentially causes the images to be so big. So if we say du minus sh, this is for disk usage, so we can see the size of the folder. And we say .next, that's 6.6 megs. And then du minus sh node modules. Node modules is 243 megabytes. That's also going over to the resultant image, and we don't want those things to be part of it. So what you do to make it even smaller is you go into the next.config.js file, this one over here. So this is specific to Next. Obviously, when you work with other libraries or frameworks, you'll have to go and figure out how you can make it as small as possible, whatever it builds. But in this case, if you make in Next.js, you change the output to be standalone, and you do an npm run build. I want to open this folder so you see it come in there. Npm run build. So now it's doing a standalone version, and there we can see standalone directory appearing there. If we now take this Docker file and change it up a bit, so maybe if I could just go back here. This is the normal Distroless one. What we did is we said copy from build, user source app to user source app, and then change the work directory to that, and then we just fire up next start. The way we change it now is to say, okay, instead of copying the entire .next folder, or in fact the entire project, copy from the .next folder in standalone. Just take everything that's in there and copy that into user source app, change your work directory to that, and then in standalone, there's a server.js, and that's what you execute. So now, if we say docker build current directory, we give it a tag of compare node Distroless smaller, and we run it. Now it does the multi-stage build. So step one is to just build the app, which is what it's busy with now. And I don't actually have to wait for it to finish, but I want to show you how it works. So I did do this earlier, but let's pretend like it hasn't been done yet. Right, so now it's finished. If we now check out the size of this image, in fact, forget about the size. I'll show you the size just now. But if we try and run it, docker run, we map the ports, we give port 3000 as the default run, and then which one are we running? The tag of node Distroless smaller, yes. So if I run that, it says listening on port 3000. Let's exit this presentation, localhost 3000, there we go. The Next.js app is actually running fine on port 3000. So what's the size of this image? If we do a docker image ls, we'll get all the images that we just built displayed here, but the last one we did was 166 megabytes. And that is as small as I was able to get it. If we just switch back to this presentation here, so no Distroless, this was the previous one, 448 megs. That still included all the node modules and all the other files in that directory. But once we trimmed it down a little, we changed the output to standalone, and we changed which files are copied over, we're able to get it to 172 megabytes. That's when I did it earlier. The recent one was 166. Does vary a little. I mean, I think that's decently small and very impressive. So also, there's a lot less vulnerabilities involved here because the entire node modules directory is not present. It's literally just your app minified code in as thin a distribution as you could possibly get it. So, I mean, that's a mouthful. I've been discussing a lot of stuff. Please go back and forth and look at it again if you want to. I will also put this presentation in PDF format in the repository. I'll link everything down in the description. Just in summary, these are all the different builds I did. So the Distroless smaller, obviously being the smallest one. Distroless itself 448. So if you don't go Distroless smaller, in other words, where you copy the standalone directory over, your next smallest option is the Alpine build. But remember what I said about the C libraries there. And then if that's still not quite what you want, just go for the Node default build, but add the slim tag on there. You'll get 490 megs. I think that's still decently small, considering about 250 to 300 megabytes of that is actually the NodeJS app. So you're talking just over 200 megs for the base image. I think that's brilliant. Yeah, thanks for watching again. This, like I said earlier, this is a remake of a previous video that actually broke. It stopped, everything stopped moving on the, I think 15-minute mark or something like that. So I decided to put a bit more effort into presenting it better. And yeah, please like and subscribe and share. And I hope to see you back for some more in the future. Thanks a lot. Stay well.